Yeah, so I just want to do a little bit of an update, everyone, just to see how I was getting on with traffic. It's a far more complex than I was expecting. And what I've done is come back to my city, and I'm just going to quickly jump into traffic notes here. You can see I've set up a very simple road network here, just for testing purposes, because there's two issues. One, which you'll see in a second, is that this crossroad, although there's crossroads that allow you to go both directions, the cars just jump in front of each other. It's a bit of a chaos. And then the other one that I've been talking about in the forum is this T-junction issue, where if I've got a car travelling down this road here towards a junction, it pays no attention to the ongoing traffic and just blows out right in front of it. So what I'm going to do is just save this off and see if we can demonstrate those problems. Add 10 cars. Now you can see if they're I'll add 15, a bit more taxing. So you can see as they come along here, it's total chaos, and they've instantaneously just jammed up, logged up completely. Now what you're not seeing is the problem on the other side of this junction, whereby if the car was coming down here, it's just going to pull out, and if there's one coming, it'll smash into it. If there's one coming toward it the other direction, it'll smash into it. So total chaos. So I'm going to come out of there just now, and I'm going to rerun it so that everything's reset. I'll just load up my city, and I'm going to do two things. So if the crossroad problem, I'm going to add some traffic lights, and that will hopefully control the traffic to stop it from ramming into each other. And then for the T-junction, I'm going to show you how the watcher system works. Now this is still quite early in, and I've got quite a lot of things I've still got to sort out. For example, the cars don't actually rotate yet, the cars don't slow down at junctions. That's been disabled for this test. The roads don't have a capacity limit, so when the cars generate, they randomly generate, and they, as you see, they were generating on top of each other, etc, etc, and occasionally for some reason the wheels vanish. But anyway, so first thing I'm going to do is I'm going to come in here and I'm going to create my traffic lights. So what I'm going to do is I'm going to come here, I'm going to hit a traffic light. Now this is a simple model, so all it is I've knocked this up in Blender. It's a very simple traffic light, an arrow and a plane. Now the plane is the important part, because as you can see there, it's single-sided, which means it's only collidable from one side. Now in the actual game, obviously you wouldn't have the model here, you wouldn't have the arrow here. The plane is what's important, and effectively the plane controls only this flow of traffic, because if the car's coming from this way, it doesn't collide it. If the car's coming this way, it does. So that's effectively a red light for cars coming down this left lane. So if I go into the other side of this junction and create a new traffic light there, see this one is opposing to it, so it is now effectively a red light for cars coming the other direction, and stop. But it doesn't stop cars going down. And lastly, I'm going to add a traffic light here. Now this one, I'm going to rotate it around so it points this way. Now at the moment I can't control individual cycles, but these are on opposing based on their horizontal and vertical position. So effectively these two traffic lights will go green while that one's red, and vice versa. Now, as I said, the models won't, the traffic lights and that etc here won't exist in the game, but the concept is very simple. On the alternating cycle, which you'll see in a second, all it does is when the traffic lights are red, it places the plane across the road. When the traffic lights are green, it takes all those corresponding ones and moves them below the surface of the road, so they're no longer collidable by cars. And that's how we control it. So we'll see how that works. Now we've got to sort out this T-junction issue. So how do we stop cars just pulling out into oncoming traffic? Well, we add a watcher. So this time I'm going to add a traffic watcher, and again, this icon, this iconosphere, is just for my debugging purposes so I can tell them apart. But it's the plane that's important. So again, it's a single-sided plane, it's only collidable from one way. Now this one's much narrower and only blocks the lane. So when a car comes up here, it's going to detect that. Now what the AI does is it looks and thinks, okay, so I've hit a watcher, so it queries it. So what does that mean? So once the watcher's queried, what I need to do is I want to check out traffic coming up this way and traffic coming down this way. So I have to go out to here, and I'll do add a watcher node. Now this watcher node, if I click it and rotate it around, allows me to say what direction that's watching in. So they're linked to this one here because it's green, and what this is doing is now pointing down this way, and it's going to cast a ray when it's queried round about there-ish and say, can I see anything? And it will return a yes or a no back to the actual watcher. What I'm going to do is select the watcher, I'm going to add a second node for it, this one here. Now this one, I'm going to point in the other direction. So now what will really happen is if a car comes along here and it hits this and detects that's present, it will then send a query to this watcher and say, am I clear to pass? So that watcher responds to that by first going to this one and saying, can you see anything coming that way? Then it will ping to this one and say, can you see anything coming that way? And then it will return the answer to the car. Now if they're both a no, the car will go. If it's a yes, I can see something, it won't. Now again, these would be invisible in the game, but for debugging purposes I've got these models to represent them, and they're green and red. So as you'll see, as a car will come and query this, they'll turn green if it can can't, if neither can see anything, they'll turn red if it can, and if either of these watchers can see something, this car will wait until the road is effectively clear. There goes the theory. So let's just save all that off. Again, here you can see the timer here, so traffic lights are going to change every 15 seconds at the moment. So these ones are red, so they're going to block traffic going up and down, but not across this way here. But you'll see in a moment when they change. And they rotate round. So now you can see this one is now swapped over. So what I'm going to do is I'm just going to add back in some cars. And you can see these cars here are moving quite happily along these traffic lights. Oh, something's gone wrong. Don't know why it's in that. Now, here's a perfect one. So it's hit the watcher, but that one could see a car coming, so it wouldn't let them pass. Again, the traffic lights are stopped. Cars can pass through them that way, no problem whatsoever. Lights change, and traffic goes about its business. Now again, you can see there, I don't know what's going on with the traffic lights here. This car should be passing through. There's something going glitchy, but you can see when that hits it, it will stop the traffic. So let's see if it's going to do it again. Well, there's nothing coming the other way, typically enough. But anyway, I'm not quite sure why the traffic lights are glitching. I think I've changed the raycast distance, and that must be affecting it because it's all done in sphere casts now. But you can see here again, see this one's been stopped because it says, oh, something coming, but now it's free, you can go. So the watcher system actually works quite effectively for this type of junction. It stops traffic pulling into it, and the traffic lights were working completely fine, but there's something going wrong with the raycasting on there, which would, and I've tried this in a bigger environment, stop these cars from interlocking with each other by stopping the traffic. So there's actually a lot more work involved into recasting for cars than I anticipated. Here's another example here. You can see the traffic still trying to turn right through oncoming traffic, so I've still got to try and work out a way of saying, adding some kind of watcher to the traffic light that says, well, if you're turning in this route, you can only actually do it. Now the way I'm thinking I'll have to do that is as I link them together. Oh, there's something glitchy there in the way that I've set up the network. If there's something, when I'm linking the traffic nodes around, I'm going to have to link those two watchers so that if the vehicle gets to here, it's got an option to go ahead or to the right. What it's actually going to do is query to the right and say, well, is that road completely clear? Because I can't turn that way if it's not. But that's just an extension of the watcher system which is built. So what I'm going to do is I'm just going to quit this out because obviously my traffic lights are glitchy. Get rid of the traffic lights. Data. I'll leave the watchers in. So this time it loads up. I won't have the traffic lights anymore, so I've just erased that data, but I will have the watchers. Which means we can see how that T-junction performs a little bit better once I've got a little bit less traffic being held up at the traffic lights at the other end. Through my road and just make sure I've still got my watchers. I do. Take that off. Right. I'm going to add in, let's add 15 cars. You can see again, it's coming up here. Now both of them can see oncoming traffic, so they're saying, nope, you can't go. But now it's clear, you can. So again, it's going to come to there and say, oh, traffic from both directions, can't go. Oh, this time it can only see traffic from one direction. So that's how the watcher system works. So it's essentially the car's going to come up, it's going to query this node, and if it can see something coming from either direction, it's not going to do it. And you can see there's still an issue with cars that are, the collision effectively runs from the bonnet forwards, the tip of the bonnet forward, so that when they're generating, they appear on top of each other. So I'll have to sort that next. But that also applies to pedestrians. You can see here, if I zoom in a bit, the T-junction works completely well now. So if the cars are coming along, it stops them. Now what I could add, a few extensions to this, is so if a car is coming down and intends to turn down the junction, it doesn't stop the traffic. Or indeed, if a car comes along here and it wants to turn to the left, then it shouldn't be stopped by traffic coming along the top. So there's a lot of complexity to actually getting this AI traffic to navigate around the city, more than I actually thought to begin with. But the challenge is keeping the number of raycasts that are done down. So at every stage, it's much quicker to check things like vector 3 distances than it is to do a raycast, and you check specific objects. So every car, when it's moving, is checking against every other car, but only raycasting against them if they're within a certain range of it. And similarly to all the traffic lights, the watchers and everything else, the watcher only casts when it has to, You can see there's that pass through it that jumped up there a little bit because it was saying, right, I've queried it, so they've had to cast. And again, these will only cast against cars, and they'll only cast against cars that are within a certain distance of it, so it's relatively efficient, so that I'm not doing eons of recasts everywhere along the way. I think there was a glitch there in the colour coding of that one, because it was staying red but it wasn't actually detecting anything. As they would normally be invisible, the point is it's detecting the vehicles coming and it's stopping the traffic from moving through. Slow but steady progress.